The only difference when we're subtracting complex numbers is that we just have to subtract their real parts. So 9 minus 8 is 1. And we have to subtract their imaginary parts. Now we have to be careful here. 8i minus negative 3i is actually plus. So 8i plus 3i is 11i. Now you might be wondering, what does the number I represent? It sounds like it's a variable, but it does not vary. It is always equal to the square root of negative 1. So anytime you have a radical that has a negative number underneath it, like this one in example 2, there's going to be an I in your answer when you simplify it. So basically, the square root of negative 4 is equal to the square root of negative 1 times the square root of positive 4. Well, the square root of negative 1 is the number I, and the square root of 4 is 2, at least the principal square root, which is what we give here. So this simplifies to 2I. So we can do the same thing with part B of example 2. We recognize that we're taking the square root of a negative number. So that's like taking the square root of negative 1 times the square root of positive 17, because negative 1 times positive 17 is negative 17. Well, the square root of negative 1 is I. The square root of 17 cannot be simplified. There's no perfect square that divides evenly into 17. And therefore our answer is just I times the square root of 17. But if I have one like part C of example 2, where I want the square root of negative 24 and I'm asked to simplify it, well, obviously that's got a negative underneath the radical, so there's going to be a square root of negative 1, which is equal to I. But what about 24? When we think about our perfect squares, 2 squared, 3 squared, 4 squared, and so on, the largest perfect square that divides into 24 is 4, and it goes in 6 times. So the square root of 24 can be broken apart into square root of 4 times square root of 6. Square root of 4 is 2. So we end up with 2i times the square root of 6 as our final answer.